Dear students, I believe you've been studying well and doing your best to stay safe. It's time for chemistry lesson once again. Please get yourself ready for the class. The topic for the day is acids. And during this first segment, we shall try to consider acids in nature, classification of acids. So let's start right away. Acids in nature. A lot of natural substances contain acids. Examples include citrus fruits, e.g., oranges, lemon, lime. Number 2, milk and proteins. Number 3, pepper, all types of pepper. Number 4, tomatoes. Number 5, the gastric juice, that is the digestive fluid in the stomach. Many other fruits and vegetables and household substances contain acids. Let's go straight away to look at classification of acids. Broadly, acids can be classified as 1, organic, 2, inorganic. Organic acids are mostly found originally in natural substances. A lot of them, however, have been prepared in the laboratory. Inorganic acids are also called mineral acids. Most of them are synthetic, that is, man-made. A few are found in natural substances. Let's consider examples of organic acids and their sources. Number 1, lactic acid, found in milk. Number 2, citric acid, found in citrus fruits, e.g., orange, lime, and lemon. Number 3, amino acids, found in proteins. Number 4, fatty acids, found in fats and oils. And number 5, tartaric acid, found in pepper. We shall now consider examples of mineral or inorganic acids. Number 1, hydrochloric acid. Number 2, tetraoxosulfate 6 acid. Number 3, trioxonitrate 5 acid. Number 4, trioxocarbonate 4 acid. Number 5, tetraoxophosphate 5 acids. Acids can also be classified according to their strength and concentration. The strength of an acid is a measure of the content to which it can ionize in solution. The concentration of an acid is a measure of its water or acid content in solution. We shall now consider classification of acids according to strength. Acids can be classified as 1, strong, and 2, weak. A strong acid ionizes completely in solution. A compound ionizes when it breaks up into its constituent cations and anions. All the hydrogen ions in a strong acid are converted into what we call hydroxonium ions. Hydroxonium ions are formed by the reaction of hydrogen ions with molecules of water. Quickly, a few examples of strong acids. Number 1, hydrochloric acid. 2, tetraoxosulfate 6 acid. And 3, trioxonitrate 5 acid. Before we time out to continue in the next segment, please write down this activity. That's the first activity for the lesson. And it is this: search online and A, write a list of 5 other fruits and vegetables apart from those already mentioned in this lesson so far that contain acids. Number 2, create a list of 5 household substances that contain acids. And number 3, create an album of pictures of fruits, vegetables, and household substances that contain acids. We shall time out here and continue later. Thank you very much. Welcome back. We ended the previous segment by defining the strength of an acid as the extent to which it can ionize in solution, and we gave some examples. So let's start this segment with weak acids. A weak acid ionizes only partially in solution. Not all the hydrogen ions in the molecule of a weak acid are converted into hydroxonium ions. Example of weak acid. The commonest example of a weak acid is ethanoic acid. It ionizes in water to liberate only one hydrogen ion, hence only one molecule of hydroxonium ion. Please quickly write down this activity. Write equations of reactions to show the formation of hydroxonium ions when each of the examples of strong and weak acids earlier mentioned reacts with water. You will do this activity, please, after the lesson. The next thing we have to do now is classification of acids according to concentration. Acids can also be classified as concentrated or dilute. Concentrated acid has little or no water added to it. Dilute acid has a reasonable quantity of water added to it. Sometimes the water content in dilute acid is more than the acid content. Please write down this activity, and I would love you to do it after the lesson. It is titled Test for Acids in Foods and Fruits. The materials required are baking powder and any or all of the following fruits: orange, lime, lemon, pineapple, or tomato. And here is what you will do. Squeeze or blend the peeled fruit and sieve to extract its juice. Ensure the volume of juice extracted is about half standard glass cup. Pour the extracted juice into a cup and add a teaspoon of baking powder. You will observe or perceive this, a fizzling, which means bubbles of gas are produced from your mixture. The gas produced is carbon 4 oxide. Only acids liberate carbon 4 oxide gas from baking powder. Remember, the chemical component of baking powder is sodium hydrogen trioxocarbonate 4. The process in which a gas is liberated during a chemical reaction is called effervescence. Let's move on now to definition of acids. We shall consider 3 definitions. 1, Arrhenius definition. 2, Bronsted-Lowry definition. And 3, Lewis definition. Arrhenius defines an acid as a substance which, when dissolved in water, produces hydrogen ion as the only positive ion. Bronsted-Lowry defines an acid as a proton donor. The hydrogen ions produced when an acid dissolves in water are the protons referred to here. Lewis defines an acid as an electron pair acceptor. This is because the hydrogen ions produced when an acid dissolves in water require electron pair for neutralization. We will time out here once again, and we shall return later for the concluding part of these lessons. Thank you for listening. Enjoy your break. Welcome back from the short break. Let's start by doing something on word power before we continue with chemistry. I mentioned an expression effervescence in the last lesson. It is spelled EFFERVESCENCE. Now let's start this lesson with a short activity. Can you please write down this question? Write down 4 synonyms of effervescence, 4 other words that mean the same thing as effervescence. Straight away, let's go to our chemistry lesson. We shall consider uses of acids. To handle this topic, we'll pick a few specific acids. Number 1, hydrochloric acid. This acid is used for salt production, for removing stains from metals, production of drugs. Number 4, digestion of food in the stomach because it is the major content of gastric juice. Number 5, it is used in the production of organic and inorganic compounds. The second acid to be considered is tetraoxosulfate 6 acid. This acid is used as a dehydrating agent in the production of fertilizer, production of synthetic dyes, detergents, pigments, and drugs, and lastly, manufacture of explosives. The next acid is trioxonitrate 5 acid. This is used as a strong oxidizing agent in chemistry and also for the production of nitrate fertilizers and dyes. Citric acid, number 4, is used to manufacture food or fruit flavorings and at the same time for preservative agent in foods. Benzoic acid is a major food preservative. Ethanoic acid is used to produce vinegar. That's the substance your mothers use when preparing fruits or vegetable salads. Ethanoic acid is also used in the production of dyes, pigments, paints, coating additives, cleaning and degreasing agents. That's when you want to remove grease from substances. Ethanoic acid is very useful. Number 7, fatty acids. These are essential for proper brain functions. They are energy providers in living tissues. They are also essential for oxygen transport in the body, as well as for production of healthy skin. Lastly, let's look at amino acids under this segment. Amino acids are basically found in proteins, and their major use is the repair of body tissues. Quickly, let us consider physical properties of acids. Acids are corrosive. That means they have burning effect on the skin and on surfaces on which they come in contact. So you must be very careful when handling acids. Dilute acids are sour in taste. The sour taste of unripe fruits is due to the high concentration of acids in them. Please, when you get to the laboratory, never taste anything. Number 3, acids turn moist blue litmus paper to red. Quickly, let us consider chemical properties of acids. 1. Acids liberate carbon 4 oxide gas from trioxocarbonate 4 compounds rather. This is what was demonstrated earlier in the lesson when fruit juice was treated with baking powder. Number 2, acids liberate hydrogen gas when reacted with metals. And number 3, acids neutralizes bases to form salt and water only. Please quickly write down this activity again, and you will do this as well after the lesson. The materials required are iron filings and vinegar. Add about 50 cm cubed of vinegar, that's just about 1/4 of your glass cup, to iron filings obtained from filing a knife. Fizzling, which shows a gas is liberated, is observed. The gas liberated is hydrogen. I believe you have enjoyed this series of lessons on acids. Please take time to ruminate over what you have learned and ensure you do your assignments. Thank you very much. God bless you.